In this lesson, we will learn how to use a formula to find balance for the continuously compound interest using the number e. E is called Euler's number. So before I introduce you to the formula, I wanna briefly just introduce the number e. E is another irrational number like pi. It's called Euler's number e. Definition of e is 1 plus 1 over infinite to the power of infinite. And I know it seems really complicated. For now, you just remember that, okay, e is approximately 2.71828, about around 2.7. The number goes on forever, ever, so it's irrational number. You cannot write that in fraction, just like pi. So just kind of introduce you what does that really mean. I just grab y equals to 1 plus 1 over x to the x power. So this is a function. So if x approaches infinity, that means you plug in really large number into x, and the graph approaches to a certain number. See how the graph just kind of goes almost a straight line here. That means there's an asymptote here, that the graph approaches infinitely but never touches it. So for example, if I click 65, when x is 65, y value is 2.698. If I keep going to bigger number, maybe like 100, if I plug in 100, the y value is 2.705. If I move on, maybe like 200, then x becomes 2.712. So the y value never never shoot up. It only approaches to a certain number, which we call e. So number e is has a lot of real world application. You're gonna talk a lot about e when you go to pre-cal or especially calculus. So for now, just remember that e is another irrational number that we use. Its size is about 2.7 something. So let's move on to our formula. The formula includes e, that's why I wanted to introduce. Formula for continuously compound interest goes like that. So a means the amount in account at the time of t. P means the principal. Principal is just a fancy name to say the initial money, the money that you deposit in the beginning. R is the interest rate, T is the time in years. So A equals to P times E to the RT. So just be careful, R times T is the exponent. It's not P times E times R times T, it's E to the power of RT. So let's look at this example. This is one example in your handout. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. So the word here, compounded continuously, is something important. If I didn't have this word, then you can just use the normal interest formula. But since they say compound interest, compound continuously, then we have to use that formula. So how much will you have in the account when you enter high school 4 years later? Express the answer to the nearest dollar. So this was the formula that we talked about, and here are the key information. You deposited $3,000 and you got 5% annual interest, which compound continuously. And then you have 4 years. So after 4 years, how much you're going to have in your balance. So we know principal, P is a principal, which means the initial money is $3,000. R is an interest rate, which is 5%, which we can convert to 0.05. T is a number of time period, in which case it's 4 years. Because we was talking about annual interest, we are just counting years, so it'll be 4 years. If I just plug these numbers into our formula, I will get A, the amount, equals to 3,000, which is a principal, times E. E is just a number, to the power of R, which is 0.05 times T. So we can calculate that 0.05 times 4 is 0.2, because 5 times 4 is 20. So I just simplify that as 0.2. Now to get the value of this number, we need a calculator, because we don't really know the exact value of E. So if you use the calculator, I'm just gonna plug in the number here. So E to the 0.2 is about this number. So we have to find E to the 0.2 times 3000. So from this number, I'm just gonna multiply 3000 and we get this number, which is 3664. So that means after 4 years we will have $3,664.